Hey guys, so here is part 2, the day 4. We are going to be talking about evaluating logarithms without a calculator. Okay, so let's look at the first one. We have log base 4 of 64. Now for all of these, what we're going to do is set them all equal to x. Okay, so go ahead and do that for all of these problems. We need to make sure that they're all set equal to x. Okay, the next thing is we need to change all of these into exponential form. Okay. Okay, so let's just do the first one first. So part A, log base 4 of 64 equals x. Let's change that into exponential form. So remember, our base here is 4. Our x, or exponent, is going to be x. And then our y, or answer, is going to be 64. So here, the idea is that I'm trying to solve for x, meaning I'm trying to think 4 to what power gives me 64, okay? Well, this one's kind of easy, right? We can already think about what that value is going to be. In this case, x is just going to be 3. And that's all you have to do. So remember, we kind of did some of these, right? When we first talked about just finding what the x value is, when we first talked about logs, well, we're kind of going to do the same thing here, okay? Okay, let's look at part B. We're going to do the same thing. So we are, once again, we already set it equals x. Our next part is to change to exponential form. Okay, so our base here on the log is 5, so that means the base on the exponential is going to be 5. Our x is x, and our answer is 0.2. Now here, this might be a little bit difficult, right, to figure out, well, what is x going to be? So actually what I'm going to do now is actually change that decimal into a fraction. And maybe that will help us figure out, what x is going to have to equal. So 0.2 as a fraction is going to be 1/5. Okay. Now we actually can figure out 5 to what power gives us 1/5, okay? Well, let's think about this. We are going from a whole number to a fraction. Well, what usually is our exponent when we do that? It's negative, right? So when we go from a whole number to a fraction or vice versa, we always have a negative exponent, okay? Now let's think, we're going to think about this 5 and the 5 in the denominator, okay? 5 to what power gives us this 5 in the denominator? Well, that's going to be 1, okay? So if we have x equals to the negative first, and we can check our answers to make sure that worked, right? So if I have 5 to the negative first, well, I flip that fraction, and 5 to the first is just 5. So that works out, okay? So you can always check your answer if you need to, even in your, just to see if that works. So x equals -1 is the correct answer. Okay, let's go and do part C. We're going to do the same thing. Since we already set it equal to x, I'm going to change to exponential form. Okay, so 1/5 is my base on the log. That means that has to be the base of my exponent. X is going to be x, and then I'm equal to 125. Okay, we're going to do the same thing here. So we don't need to change because we don't have any decimals. We don't need to change it to fractions. We already got everything, so we're good to go. So make sure when you're doing these problems, just make sure either the numbers are whole numbers or fractions, and makes it so much easier. Okay, now notice we are now going from fraction to whole number. What happens when we are doing this? Well, that means we are going to have a negative exponent. Because remember, anytime we either go from a whole number to a fraction or vice versa, meaning a fraction to a whole number, we will have to have a negative exponent. Now, we are going to take this base of 5, this denominator of 5, and determine 5 to what power would give us this 125. Well, that would be 3. So that means our x here is going to be -3. Now, we can always check this. So let's go ahead. I have 1/5 to the -3rd, okay? Well, first, when I do that, I can flip the fraction, so that becomes 5 to the 3rd, and 5 to the 3rd gives us 125. So I did this correctly. That means this is the correct answer there. Okay, let's do the last problem, part D. As we have done for all 4 of these, we're going to change to exponential form. So if you want to pause the video and try to do that on your own so you can just get more practice, that might be a great idea, okay? Okay, so the base on our log is 36, so that has to be the base on our exponential. We have 36 to the x equals 6. Okay, now notice that we both have whole numbers, okay? So anytime, excuse me, you have both that are whole numbers or both that are fractions, then that exponent is going to be positive. So we know this is going to be positive. Now, let's kind of think about this. 36 to what power gives us 6? Now, some of you might be saying 2, correct? Well, we do actually 36 to the second power. That actually is going to give us a huge number. So, like, if you want to just plug that into your calculator just to check, we're just checking here. Well, 36 to the second power is 1296. So that doesn't work out, right? And we know 36 to the first power, well, that just gives us 36. But what other types of fractions or other types of exponents have we talked about? Well, didn't we talk about in our last chapter about rational exponents, right? Could this x be a maybe 1/2? What would that 1/2 represent as an exponent? So we had 36 to the 1/2. How else could we rewrite 36 to the 1/2? Remember, we can rewrite from rational exponent to radical notation. So remember that 1/2 actually also represents square root of 36. And what's the square root of 36? It's 6. So don't forget, you could have fractions as your exponents. So your exponent could be positive, it could be negative, and it could be a fraction, okay? So remember those rational exponents, what we talked about from last chapter. Okay, we're going to continue on with evaluating logs without using a calculator. Now we're going to talk about inverse properties. So we've talked about, finding the inverse. Here are inverse properties. We know log and exponentials are inverses. So when we take the log of an exponential, or vice versa, the exponential of a log, what happens is that it cancels out. Okay? And we learned that when we did composition of functions. When we did composition of functions and things canceled out, right? Okay. So that's what we're going to be doing here. We're canceling things out. Okay. So when you have the same base, b and b, what happens is they cancel and then we're left with whatever is there. Same thing when we have an exponential to a log, whatever is that x, that's going to be your answer. So we're going to evaluate these logs without using a calculator. Okay, so for the first one, we have 10 to the log of 4. Now you might be wondering, well, that log, it doesn't have an x or a base to it, right? But remember, when you don't see that, what type of log is that? It is a common log. So that means the base is 10. So if I rewrite this, I have log base 10 of 4. Okay? So remember, anytime you really don't see that base, that means it's a common log and the base is 10. Now we look at the base of our exponential and the base of our log. Are they exactly the same? Yes. So since they're exactly the same, what happens is that they cancel each other out. And so all we're left with is that number 4, and that's going to be our answer there. Okay? So you have to make sure the base on your log and the base on the exponential are exactly the same, then you can cancel out. Well, let's look at the next one. We have log base 5 of 25 to the x. Now, the base of our log, which is 5, and the base of the exponential, which is 25, the same. Now, but we can rewrite some things, right? We can change maybe that 25 so it does have the same base. So I'm going to keep my log base 5. And I'm going to change that 25 into a 5. Now, I can't just magically do that, right? But I can use some algebra properties to rewrite. Well, let's think about this. 5, maybe to what power gives us 25? That is going to be 2. Now, I do need to keep that x, because that doesn't magically go away. Now that I have the base of my log and the base of the exponent exactly the same, they can cancel out. and all we're left with is that 2x, and that'll be our answer there. Okay? Okay, I would like you guys to go ahead and pause the video and try part C. So try to do 8 to the log base 8 of x. Okay, let's see what you got. Well, notice that the base of the exponential, which is 8, and the base of the logarithm, which is also 8, they are exactly the same, so they can cancel out, and all we're left with is just x. So that was a nice easy one, right? So just like what we did similarly in part A. Okay, now I would also like you to pause the video again and try part D. So evaluate log base 2 of 64 to the x. Okay, let's see what you got. So notice the base on our log, which is 2, is not the same number as the base of our exponential, which is 64. However, we can use algebra to manipulate or rewrite things. Okay, well, I want to keep my base exactly the same, so I'm going to have 2 for my exponential there. But I can't just magically change 64 into 2. So I have to think, well, 2 to what power gives me 64? Well, that's going to be 6. Okay, so 2 to the 6 is basically the same thing as rewriting it as 64. Now, I do need to keep that x there. Notice that now I have the base of my log and base of the exponential to be exactly the same. They cancel out, and so I'm left with 6x. Okay, make sure you watch part 3. That's where we're going to be talking about the change of base formula.